Hi, everybody, and welcome to the March 23rd, 2023 edition of the KCP-Edge Community Call. Thank you all for joining. The agenda is posted in the chat and in the meeting invite if you'd like to look to read along. And we also have an issue for this specific meeting. I've also just dropped that in the chat. Let me go ahead and read the contributor code of conduct. As contributors and maintainers in the CNCF community and in the interest of fostering an open and welcoming community, we pledge to respect all people who contribute through reporting issues, posting feature requests, updating documentation, submitting pull requests or patches, and other activities. We are committed to making participation in the CNCF community a harassment-free experience for everyone, regardless of level of experience, gender identity and expression, sexual orientation, disability, personal appearance, body size, race, ethnicity, age, religion, or nationality. So hello, everybody, and welcome. If there are any new members in the audience that would like to speak up and introduce themselves, you can do so now if you'd like. All right. Okay, so let's get started. I have the issue open now. I'll share it. And bookmark. Okay. All right. So first up, we have Jun Duan, who will give us an update on the EdgeScheduler. Jun?
Sure. EdgeScheduler is part of the EdgeMC components. What I'm doing in the past 2 weeks is to basically implement it. So the first step, which is finished, is to reshape the structure of the EdgeScheduler. What mainly done in that PR is to consolidate the structure of the scheduler so that it uses only one single controller to work on 3 different kinds instead of multiple controllers and each of those controllers working on one single kind. That's mainly what is done in that PR. The second thing following that PR is to do some refinements. Those are relatively minor changes about the best practices about contextual logging, naming conventions, and removing hard-coded stuff and cleaning up legacy code. That's about the second PR we have. And then we discussed and defined some internal data structure for the scheduler so that the scheduler can do the reconciliations in an incremental manner instead of have to have to get a holistic view of the data every time. With that defined, we were able to work on the specific reconciliation logics for each kind. We have to work on 3 kinds: the think target, location, and edge placement itself. We have just merged the logic for, and then the second part for location is under review right now. And we are going to continue working on the last part, which is not listed here, for the edge placement itself. So that's our recent progress on working on EdgeScheduler.
Okay, Jun. Is there anything blocking you at this moment?
No, I think everything goes well. I'd like to thank reviews from other persons, especially from Mike, which is doing the most part of the review. So I think everything goes well.
Okay, thank you. All right, so next up, sorry, was there a question?
No, just saying thank you.
Okay. All right, next up, Braulio. Would you like to give us an update on the Dev-env or the Cloud-env?
Yes. So I'll start with the Cloud-env. So we want to build a cloud infrastructure where we can test and deploy and test the KCP-Edge at scale. So to achieve that, we are building our infrastructure on AWS Cloud, and we are designing Ansible playbooks to deploy the infrastructure, and also to deploy the HMC components along with the KCP and monitoring. So right now we have the automation to deploy monitoring. So we are using Prometheus and Grafana, using Ansible playbooks, and then also we have most of the automation to deploy the AWS infrastructure. So we are just polish them up and retesting it. So the last component is to the automation to deploy KCP and the P clusters at scale per se. And the stuff we are working on, and we had a discussion with the Adam from the POC community. So on the last POC, on the last KCP community meeting, he presented some Ansible automation to deploy KCP as a process. So we are planning to take advantage of those playbooks, and also we have been in discussion with Adam to see if we further can build automations to deploy the Ansible automation to deploy the sync as in the P classes.
Okay.
And regarding so now regarding our dev test environment, we have been our goal is to use the KCP playground to deploy the KCP server and most of the components required that we can deploy that are required for the KCP-Edge. So right now we are experimenting with the KCP playground and trying to identify some missing features, some gaps, and see if we can circumvent these gaps, at least for now, and to deploy the components that are required for KCP-Edge. We can, and then but in the future our goal is to build a module for KCP-Edge that we can we can import to the KCP playground to deploy all the required features for the KCP-Edge.
Okay. Any comments or questions for Braulio?
Well, this does touch on a question here. So far, I have not worried about containerizing things. Since we're still developing the processes, it's more convenient to debug them non-containerized. But it sounds like the plan is that they will be containerized. So that raises the question of where do we put the images?
For which environment are you talking, for the dev or for the cloud environment?
The answer may be different for each, but the problem arises probably for each. Although maybe the dev doesn't containerize. So I'll just throw it back to you. For any case where we're running these are the Edge MC processes in containers, we need a place to put the images.
So for the cloud environment, we can one option we can deploy them using the ECR and just using the AWS repos to push all the required image. And for the dev testing environment, we can use a local Docker registry.
Or not. I mean, I think you were suggesting maybe we just don't, and we just run them as processes.
Yes. At this stage, we run them as process. For this current POC. But in the future, when we have them run in containers, we definitely we can follow these and other approaches.
Right. I mean, for example, I have a registry at Docker Hub. I can put images there. That's easier than running my own registry.
So for the dev testing environment, if we have a registry, that should be part of the for the automation deployment, so that you don't have to do any only configuration on your own. So you should just deploy and start playing with it.
Okay, thank you.
Any other questions or comments for Braulio? All right, thank you, Braulio. Okay,
Thanks.
up next, we have Mike for Placement Translator. Give us an update, Mike.
Sure. Yeah, let me share my screen. So I've, been working through this thing. So as you recall, we've defined it to consist of 4 major pieces, and then the 5th piece, which is importing the scheduler results. So again, if you look at this declarations file in the placement package, let me just close up the other. All right, in the EdgeMC repo, if you look in the placement package, you'll see this declarations file, which is about how we divide up the the placement controller into these pieces. And so I've implemented the what resolver piece right now, and there's in the main, this is just gets connected to something that does dummy printing. So that's something you can run. It's described in our documentation here. Basically, you can run through this example scenario. Let's see here. Why can I not? Here it is. Right. So we have this example scenario documented, and the placement translator. You can run up through the beginning of stage 3, where the placement translator starts to do its work. It only does, as I said, the what resolver part of it. So right now it just logs the information that that the what resolver determines. Let me call out one issue that's actually kind of common to our processes, and that is authorization and configuration. Configuration, well, let me start with authorization. So one of the things that I have not paid attention to is authorization. It gets complicated because we're dealing with, these logical clusters that are independent. And so there are issues of how you get each process authorized to do what it needs to do in each of the logical clusters, as well as for those that create new logical clusters or workspaces, how that gets authorized. TMC has an answer. The API export and binding mechanism in KCP core has an answer. As far as I can tell by looking at them, which I've only done briefly, but to the degree I've looked at them, they don't work for EdgeMC. So what I've been doing so far for authorization is running the processes that need a lot of authorization, just run them using the system :admin user, which is authorized to do everything. Now that connects also to the config issue. In the world of KCP, as you know, because it adds this level of virtualization, you can have a Kubernetes client config that points to a particular workspace or logical cluster, or you can have one that points to the base, which has a server URL that does not mention any particular cluster, and that's the one you need to use when you're going to do operations across all the clusters. So for example, the placement translator needs 2 Kubernetes client configs, one pointing to the edge service provider workspace, and one for these all cluster operations. And so what I've done is I've made it take 2 sets of command line arguments to build up that Kubernetes client config. There are a few standard ways of doing that. You're all familiar with the convention in Kubernetes of, for example, you can pass a kubeconfig file name on the command line, and if you don't do that, if you use the standard libraries, it will then look in the. So if you use the standard libraries, your main has to hook up the command line parameters into the way those libraries look things up, and if you pass a null or empty string for the kubeconfig file name. Next, it will look at the kubeconfig environment variable. And if that's undefined or empty, it'll look in, your home directory .kube/config, right? So there's a defined search path there, affectable by command line. Also, if you look in the placement translator, it uses some standard stuff that has ways of modulating that. So you can specify, for example, a particular context to pick out of that kube config. You can, so this is, for example, for the two, there's the kube config string that points to the whole file, potentially, or you can leave it empty, again, to default. But out of whatever file gets selected eventually, you can pick a particular context, you can pick a particular cluster or a particular user. Again, these are technical terms in a kubeconfig file. So you don't have to take the kubeconfig file exactly as it exists. You can modulate it a little bit further with these command line arguments. So, for example, you see here, in fact, I've set in the placement translator defaults for those that are convenient, so that if it all defaults to the kubeconfig file that KCP start produces, the defaults all just work out, and you don't need any command line parameters. And it gets the two configs and runs with it. And this is a kind of pattern that I recommend to other controllers. Have these options here to modulate the choice of cluster, context, and user, so that you don't have to, for example, copy and edit kubeconfig files. Anyway, so I've said a lot of stuff. Let me stop and ask for comments and questions.
Okay.
Yeah, thank you.
Thank you, Mike. All right, Yuji, you're up next. You'd like to take the floor and give us an update as to where you are with Syncer?
I the link.
Hi,
on
Yuji, we can hear you.
Okay, so let me share my screen. Okay, so now we are working on the new syncer called EdgeScheduler. It's a syncer for downsyncing and upsyncing the resource between the mailbox workspace and the P cluster. So this is a high-level design. So basically EdgeScheduler is sitting on the HP cluster, and the workload object on the mailbox workspace is synced to the HP cluster, and other opposite direction, the workload object on the HP cluster is upsynced to the mailbox workspace. So this is controlled by the config object called EdgeScheduler config. This defines which object should be downsynced, which object should be upsynced. And the upsynced object is accessed from the workload management workspace by API export. And this is working with the HMC component like PlacementTranslator and playbooks controller. This is ongoing work, but now we have the first implementation of the EdgeScheduler for the feasibility validation. Basically, it's so
Can you go back up? I have a question for you.
Okay.
Back up in the document a bit.
Okay.
So the API export's going to happen from the Mac, okay, from the workload management workspace, not from the Edge service provider workspace, because the workload object is defined in the workload management workspace, not in the
Well, I think,
ESP.
Andy, I think we need to be a little more specific about which API exports and which bindings we're talking about. There are multiple ones involved. So, for example, there's an API export from the Edge service provider workspace of the control API.
Yeah, got that part. Yeah.
All right. There's also API exports of the workload APIs those are actually at the discretion of the user. The export can be anywhere. We need the bindings where the corresponding objects exist, of course.
Got it. Yep. So I was looking for a complete picture of all the exports, but I didn't get it here. That's okay for now. Okay. Thank you, Yuji. Please continue.
Okay, so then Yana-san, my colleague, he actually implemented the first prototype. The edge sync can be registered into the HMC. It's a very similar command. For the normal syncer, so the same, almost same command. Then the edge syncer is enabled on the PvP cluster side, and then the edge placement. Right now that we are just pushing the edge sync config to the here, but basically it will be generated by the placement translator based on the edge placement, and workload comes here. Then he moved here based on my workplace. Then it syncs according to the edge sync. So also the renaturing is also happening in the edge syncer according to the edge sync config. So this is an overall picture that actually the Yana-san implemented some demo. Actually, we are actually using the Kyverno as a test case. So actually now the syncer is registered, and the case from now all the KCP Kyverno manifest generated from the Helm chart is deployed to the through the downsync mechanism, and Kyverno is running 2 clusters simultaneously. Then report is generated. 2 report is upsynced by the syncer. So the 2 reports can be accessible from the API export on the KCP HFC side. That's a high level demo. And now this is fully working, and we still need to work on the coordination for the internal component like the placement translator and the mailbox controller. So that part is still ongoing. So Yana did a great implementation. So we are looking forward to working on this together. Thank you so much.
Thank you. This is fantastic work. I know this is a very small critique, but for placement, I believe we're using translator, not transformer. So just update that in your graphic before you go.
Okay. Yeah.
That's it.
Thank you.
Can I ask a question for Yuji?
Yeah.
Yeah, so when you show the Helm chart install, this is using the new Edge Syncer, right? So is that correct that you are not actually running any of those modifiers? So you are not actually, once you install on the Edge cluster, the Kyverno controllers are not pointing back to the KCP workspace, right? They are just operating on the local P cluster. Is that
no mutation happens? This is just simply deploy the same.
So there is no mutation in this syncer that we have, right?
Yeah, no mutation. But as you know, there are some resources, some resource kind needs to be denatured. So those kind is auto denatured in the edge syncer. So for example, the cluster role binding and CRD for the Kyverno, those manifest is the denatured at the mailbox workspace, but before deploying it by the edge syncer, it's denatured. So so that's how it works.
One comment, I see that David has in, but one comment for that, just to emphasize, I think the Tiansan implemented the syncer from scratch, so it's not taking, the code of the existing TMC syncer with the mutating of the pods and all of that. So if you want, it's basically just passing the resources downsync. It doesn't touch and doesn't do anything on that. It's a completely new syncer.
Yeah.
David, sorry.
I thank you. Hello, Andy, everyone. I think you mainly answered my question. I mean, I was about to ask if the Edge syncer was reusing some parts of the existing syncer or completely from scratch, and mainly also what was the plan for the future of this.
So I think originally we talked about it. You remember we talked about maybe changing the original syncer, the regular syncer, to add some options so we can have our own main and reuse. I think we had those two options. I think for time's sake and, we had some, features and goals that we want to achieve. I think this was the fastest way to achieve that. And also, I think we noticed other discrepancies other than the mutating. For example, we wanted to I just saw you post about supporting the webhooks tunneling and so on, but originally we wanted to support all of that and so on. So we thought, okay, maybe it's better. And it's actually Eugene and Einstein that decided that they will create from scratch, and they completed it in very quickly. So it was the best decision.
Sure. Yeah, I mean that's perfectly okay. Just to know if the plan of sharing internal parts. I mean, because there are three approaches. We can build it from scratch. We could have a single binary and have options, but this has not been selected.
Right.
Because it would make the code more complex. And the intermediate approach is having a common skeleton that you can then, in terms of source code, that you can then reuse in a distinct binary where you omit some of the components, like the mutators.
I can just share my thoughts. Let other people. I think that probably in the future we would want to stop, look if there are some common kind of parts that we can push into a shared library, but that will require, of course, refactoring also the TMC syncer, right, to use that library and so on. So I think that's kind of in terms of reuse cost code makes sense. I will just mention that originally I thought that for other parts as well, the scheduler and so on, and that goes also to the syncer, I would be more happier if in KCP side there would be plug-in capabilities to import different capabilities and so on. And originally I saw that I got the feedback from Stefan saying, "Oh, just create your own kind of
Yeah.
And
so if I'll also offer my opinion, but it's very kind of hands off, right? I think we don't have any kind of determined position on this. We're just looking for what's most expedient as we move forward. So right, this is all to be revised in the future depending on what we find to be most expedient.
Yes, sure. Okay. Okay, thank you very much.
And of course, once it's merged and so on, we would be very happy if you and others can go through that. If you have if you didn't do that through the PR, of course, even later, if you can point out to stuff that maybe you want to observe into the TMC syncer, and then we will have some shared functionality. It will be great.
Yes, sure.
Yuji, just as a point of order, have you already placed a link to the PR in the KCP dev channel in Kubernetes Slack organization?
No, I didn't put any Slack comments.
Okay. Would you please go ahead and do so that folks like David can also benefit from reviewing?
Okay,
Thank you.
thank you.
I had a question here, just in general. This is the first time I've seen the actual reincarnation of, or the actual implementation of naturing and denaturing. Can somebody explain to me how that's pulled off? I'm very curious, because I know we've been talking about it for a long time, but I didn't know how it would be implemented.
So there's two sides. There's the denaturing and naturing. The denaturing doesn't appear in this picture because we don't have the clients of this or users, and the view that implements it also is not drawn. Actually, that's probably a serious gap in this picture. So denaturing is done on the way in from clients that have been shifted left or whatever. Renaturing, as was mentioned, is done by the Edge syncer on the way from the mailbox workspace to the Edge cluster.
Okay, wait, so you said, sorry, I have to pause you. So you said on the way into the mailbox workspace is when the denaturing happens?
On the way into the workload management workspace.
Okay. Okay, that makes sense. And then the denaturing the renaturing happens on the way out of the mailbox workspace?
Exactly.
Yeah, okay. All right.
Okay.
Wow.
So now that's kind of where it happens. How it happens.
Yeah.
Right. Yana did what I expected, which is to denature by changing the API group, by appending .denatured to the API group.
Oh, interesting.
Now that means
That's
to support that in the workload management workspace and mailbox workspace, we will need definitions of those corresponding API groups.
Yes.
My expectation was, since we need to denature only a fixed set of resources, we would develop API exports for those resources from the Edge Service Provider workspace, and then the workload management workspace could import those use API binding to those API exports to get the denatured resource definitions.
That is like uber cool. I am really impressed by that.
But Mike, one question, just to clarify, this is of course should be supported dynamically, right? It's not a one-time definition in the beginning, because we want to be able to add resources to be synced dynamically. So obviously you will need to.
Well, it's a small number.
The
Mike,
resource.
Let me just challenge this to see if I'm getting in the middle of the conversation at the correct way, and you can correct me. And so what I'm thinking I heard Mike say is that there's only a few object types that have to be, few types of API objects that have to be under a denatured heading, right? So everything else is unknown to the workspace because it's not there's no controller
Correct.
to act upon it, right?
I forgot about that. So we will create the required for everything, even if all that small group, even if they are not really used by. Okay, got it. Okay, I forgot.
No, Andy. Yes,
I didn't get it right. I thought I got it right.
I saw it in your document.
No, I think you did.
I saw it in your document. Yes, okay.
All right. Now, this touches on another topic that's later in the agenda, because the work that Yana did require configured renaturing, but I think later in this meeting we'll hopefully come to common understanding where we don't need configurable denaturing and renaturing.
This is really impressive to me. I mean, I have to tell you, I'm very impressed with the speed at which the Edge syncer was implemented. So that's really great. That's really a great display or demonstration of how the community worked together so quickly to bring about knowledge and understanding in a bidirectional way. So I'm really impressed by that. That's the first step. The second thing is this denaturing and renaturing. This is really impressive to me because I think this really will make an impact on the folks that we use this to show how we can really do what we say we will. And that has to do with, you know, first and foremost, the top of my mind goes disconnected operations. And if you're following the, you know, the gist of what I'm getting at is in the ability for us to have objects that are in either denatured or inert form sitting out there in an intermediate space, no matter how many different levels of hierarchy we may or topology we may incorporate in the future. I think that that's a fantastic leap in the right direction. So kudos to all of you. That really was fantastic. That's my comment.
I think it's all true, but I'm not sure that the disconnected operation is related to that denature. This connected operation require, you know, also support in the heartbeat and in all the.
Yeah.
I'm in a sense, disconnected is more kind of I wouldn't say aggressive, but major change in the thinker because it require you won't be able to use regular kind of controller in the both side. We will need to think about disconnected operation.
Okay. All right. So let me refactor my comments then. What I would say.
So your comment is completely fine, other than the example of disconnected.
Yeah, no, I got that part. But the scale, I think where I was going with that is more from a scale perspective, as I was thinking at how many different layers of you know, not necessarily a mailbox, but intermediate layers between the hub and the spoke we can introduce as a result of having this denaturing, renaturing process. And so for that, you know, that's the way I see it. I may be completely wrong, but yeah, you're right about disconnected operations. There's a follow-on discussion that needs to take place there. Thank you for correcting me.
I have actually two questions.
Oh, yes.
The first one is about so what Mike was saying before, that we define these API exports in the Edge service provider workspace for the denatured kind of API, changing the API group, and then they will show up in the, will be bound in the workload management workspace. So I wonder, does the client then that is actually applying or creating these objects in the workload management workspaces to now use the denatured object, the API group has to be changed by the client?
No, that's what the view is. This is something we discussed with Stefan and agreed months ago, and I was so satisfied with that agreement that I didn't bother to write it down. So that's why you don't see it in the pictures, and that's what I was calling out earlier.
Okay, that was the mystery for me. That wasn't clear how this thing works. All right. So this is really a trick that happens in the view somehow in the virtual workspace.
Yes.
Okay. The second point is, so we are sort of, I guess, doing still the importing of these definitions, this one that we need to denature from P clusters, or are we sort of hard coding them similar to what happened in the compute workspace, in the root compute workspace in KCP?
I'm not quite sure I understand that question.
So we have a few of these.
Mike, just to clarify, I think Paolo is asking exactly what we wanted also to bring up in this call and discuss later on. How do we plan to transfer the resource definition or the, you know, from the P cluster to the right, Paolo, because we need to know the resource in order to
I wonder if we have like a set of predefined denatured resources in that service provider workspace that will be maintained somehow there, or we plan dynamically to import them from the P cluster and do the denaturing. I don't know. If this is a discussion already have an agenda, we can talk when we get there. Otherwise, we can discuss.
I think you're touching on the coming agenda item.
Yeah.
David has his hand up.
Yes, I was wondering, since now you have, I mean, you are on the path of using a dedicated edge syncer, how does it relate to the discussions we had on the KCP side with you, especially Mike as well, about upsyncing rules and how the upsyncing is managed in TMC? Because as you know, upsyncing in the TMC syncer is currently fixed on, you know, small hard-coded list of kube standard resources. And so, I mean, would it still be required to provide this customization, at least on your side, on the HMC side, or not? Or would it be, managed in a dedicated way in the Edge Syncer?
So in EMC, we do need configured upsyncing. We can't have upsyncing of only some built-in resources.
Sure.
So, as long as we use a distinct syncer, then that's not a requirement to change the TMC syncer. If we aspire to share code, obviously that shared code would need to support that.
Yes. Okay. Sure. But short term. Okay. Sure.
One question or comment, maybe you can refer. As far as I could see, the reason you are limiting to those three are not technical, right? Technically, you could have upsync other resources with the same mechanism. It's just a opinionated decision you took, maybe due to access control or authorization.
Yeah, exactly.
Security,
exactly.
right?
It's security-wise, it requires much more thinking allowing that in a general way, upsyncing in a general way requires much more thinking. The same, by the way, as being able to sync cluster-wide resources. If you have a well-defined use case and limited scope, like HMC with specific, infrastructure, then obviously you can open those to, a wider set of resources. But if we want to have some sort of really general purpose mechanism, then it becomes quite a security problem. If precise rules are not defined, that would allow on the KCP side to limit everything which is either synced as cluster-wide resources or upsynced from the physical cluster. Does it answer the question? It's mainly.
Yeah, that's what I thought. I just want to verify.
Yeah, it's a security question. We really have to clearly define some, guarding rules and implement them on the KCP side before opening to more resource types.
Thank you. David, I think you're here. Okay. All right. This looks great. Thank you very much. Yes, and David, thank you for the comments on security concerns. Okay, next up, Mike, you're on the agenda for discussion of new object type.
Right. So the issue is that I initially had not considered the case of a resource, and let's just be utterly clear here, because in Kubernetes, there is some confusion over the use of the word resource. In the code, the word resource, by far predominant use of the word resource is to refer to a kind or type of object, not an individual object. This is confusing to people from the outside world because in the World Wide Web, a resource is anything with a URI or URL, and it could be an individual object or a collection of objects. But the Kubernetes code base, and this is taken also from its user-facing documentation. Its user-facing documentation is very mixed up on the use of the word resource. But I have been trying to use the word resource precisely in the sense in the code to refer to a kind or type of object. Anyway, I had not considered the case of a resource that is defined by the action of a controller in the Edge cluster. And the guys at TRL kind of expose that with their work in Kyverno because they deploy it with an operator which creates CRDs, thus defining resources. So we have to, I think, think and express clearly how we're going to handle this case. So I have a proposal that I'm going to try to go through briefly, verbally. It will be clearer if we think about downsync and upsync differently. So let me start with a review of how KCP allows resources to be defined. There are basically three ways. You can define them with a CRD, as in plain Kubernetes. You can define them by creating an API binding in a given workspace that will import definitions from an API export somewhere, anywhere. You just have to say where. And there's also a thing called an API resource import, which also can pull in resource definitions. And this is connected to, this is part of TMC. It can pull in resource definitions from a P cluster. For the EdgeMC proof of concept that we're currently working on, I propose that we allow a workload in a workload management workspace to use either of the first two mechanisms for down-synced resources. That's to say either a CRD or an API binding. Now the problem, I think the API binding will in fact be more expeditious. So in the fullness of time, so there's already a concept of built-in resources. The idea here is that when you instantiate this POC, you configure it with a list of resources that are built into the Edge cluster. And so this is a new category of things that are resources that are not built in, but are defined dynamically. And I think the most mature way of handling this would be to introduce an API by which the user can declare which resources are going to be defined dynamically at the edge, but we can start with a much simpler hack. If the user uses an API binding, which we know cannot propagate to the edge because it's not a KCP workspace, that implicitly is a way of saying, hey, this is something I don't expect you to propagate all the way to the edge, but I do expect you to propagate it to the mailbox workspace. So that enables the user to define the custom resources that are, that's to say, objects of the sort that were just defined by that API binding. Their definitions will work in the workload management workspace and in the mailbox workspace. Now, there is, in some sense, a timing constraint here. The placement translator will not be able to successfully create these objects in the mailbox workspace until the API binding has been created in the mailbox workspace. However, since it works in an eventually consistent way, we can start by not worrying about that timing constraint, and things will eventually work out. We'll suffer from some error messages in the interim if things happen to go in the wrong order for a while. Yes, Paulo.
I've heard that there is something called initializers for the workspace. So you could actually define there some logic that could be run before the workspace actually become available.
Thank you. All right. We can take that into consideration when we figure out how to actually respect that timing constraint. Ezra.
Mike, can you maybe describe what is the flow of up to creating those API bindings? Because you trigger that by the creation of something on the P cluster. So can you describe the actual flow?
No, I did not. I'm focusing on downsync first, then we'll get to upsync. Does that answer your question?
Oh, on downsync. Okay, thank you.
All right. Are there any other questions on the downsync side of this?
Yes. So going back to the discussion about denatured, assume that these predefined resources will be also some of these denatured resources that you want to sort of predefine at the beginning.
So if you look, please do review the outline of the POC. There's more than two categories of resources. There are some that are inherently denatured because KCP gives them no interpretation. And I believe the ones that are defined by the action of a controller at the edge are all in that category. So we do not need to take any special steps to make them be denatured. They're inherently denatured.
Okay, is there anything left that we have to take care of then? I don't know, cluster roles or stuff like that.
So do please review the outline. It does have a list of particular resources that are built into KCP or Kubernetes and how each one of them is categorized and handled. This is a separate discussion we could have. Let me refer you, there's also a PR about updating the thoughts on staging or rolling out staging the development. And that's part of that. But let me just wave that off as a separate discussion. David.
Okay. I think David just said that he has to go.
All right. Are there any other comments or questions on the downsync side of this? All right. Now for upsync, again, I think we could handle this with various levels of sophistication or maturity. We could start, and again, our emphasis is on starting. We can start with the simplest possible hack, which is to say that for the resources that will be defined by the action of a controller in the edge cluster, we will ask the user to put into the workload management resource workspace an API binding that also causes the definition of those resources. Because it does not propagate all the way to the edge, it will not conflict with anything that happens at the edge. And because it does propagate, we can make it, and it normally would propagate to the mailbox workspace. And thus, the resources that are going to be upsynced so for the objects that will be upsynced, their object types, their definitions will eventually be present in the workload management workspace and the mailbox workspace. So things will work. I just realized I forgot to mention which things get selected by the edge placement. But apart from that, is the rest of this clear? Ezra.
Yeah, maybe I messed up everything. Why can't you use the same approach for the downsync as well? Am I missing something? Why can't I just, if you are allowing someone to create stuff a priori and so on, why can't we do that for the downsync?
I'm not sure I understand your question. Please remember that there are two concerns here. One is the resource definition, and the other is the particular objects. So one is the object type, and one is the object instance. And I'm proposing specifically for the upsync side, the object instances flow from the edge toward the center. There's no question or doubt about that. The question is, how do we get their object types, also called kinds or resources?
Right. And for downsync, when you talked about
we went through downsync a couple minutes ago. Is there anything still unclear about the downsync side of this?
So my question is for downsync. Also, the only issue was the object type on the KCP side. At least this is what I thought.
Well, for downsync, we have to propagate both the object type and the object instances. And I went through a few minutes ago how that would happen.
But, so my question was that for object types, why can't we do the exact same thing we are doing for the object types for the upsync?
Well, I'm not quite sure what you mean by do the exact same thing. In some sense, that's exactly what I said.
Allow the user to just, define them. This is
let me repeat what I said. You tell me if I'm agreeing with your suggestion or not. What I said is for upsync, for the object types, we ask the user to include in the workload management workspace an API binding that gets those object types defined. And by the way, I'll also ask that the edge placement object selects or matches in its what predicate that API binding. And this will cause the placement translator to propagate that API binding to the mailbox workspaces, thus causing the object type to be defined there, so that when the syncer goes to propagate the object instances from the edge cluster to the mailbox workspace, it will eventually find the object type defined in the mailbox workspace.
I fully agree with that. I will take offline with you the downsync part.
Any other comments or questions?
Okay, thank you, Mike. All right, folks, just a matter of some other logistical housekeeping. I was able to put something into the Up for Grabs repo, which is a place where people find useful links to good first issues, and hopefully that'll bring some more awareness. Our YouTube channel statistics have gone up pretty significantly in terms of the amount of time that people are spending on the site to read documentation. Also, the number of events have increased, and what Google defines as an event is people clicking around and opening other documents based upon their initial entry to the site. So there's starting to be more information available, and more people are taking interest in that information. And avenues and channels such as Reddit and LinkedIn are serving as some of our best routes to find our documentation, as well as the Medium information on blog posts, of which there is a new one out there, if you haven't seen it already, by Braulio. It's posted on Medium. It's in our Medium channel. Let me see if I can bring that up real quick. Share my screen. So it's the cute one with the dogs being led. I would have chosen cats, but I respect the artistic license. I think it's a great picture. So you can read.
Dogs pull harder. Come on.
Yeah. What's the fun in cats, right? So there's a lot of good documentation and diagramming and references to all the types of things that we're trying to pull off large scale deployments of not only Kubernetes, but any of the components that are included within it and derivations of it, like KCP and KCP-Edge. And we'll continue to do this testing, as you were probably reading or viewed earlier on this call. Braulio's been instrumental in working on the Cloud-env and the Dev-env. The Dev-env is to be used on your local laptop for development and exploration and experimentation. And the Cloud-env is going to be used as a way for us to experience and experiment with Kubernetes and KCP-Edge at large scale. And so that'll be coming in the quarters ahead. We hope to be looking at doing some more scale testing at that point. But for right now, this serves as a good recap and captures the information that we developed over the course of the last year on how to scale how to scale Kubernetes in a way that leveraged common infrastructure available through AWS. So thank you very much, Braulio, for your entry here, and we look forward to hearing more from you in the future. All right, everybody, thanks for joining. Does anybody else have any other comments or questions? We're at the top of the hour and the end of our call. All right, thank you. I'll be posting this shortly. Thank you. Have a good week.
Thank you.